All right, today we're pulling back the curtain on a platform that's responsible for millions and millions of connections, Shaadi.com. We're going to break down the actual nitty-gritty architecture that powers the search for a life partner, piece by piece. So it all boils down to this one huge engineering question. I mean, think about it. This isn't just about slapping together a website. It's about creating an experience that's always on, incredibly fast, and deeply personal, all at a scale that's just mind-boggling. So how do you even begin to do that? Well, before anyone wrote a single line of code, the team had to establish their guiding principles, their North Star. First, the platform has to be up 24/7. High availability is a must. Second, searches need to feel instant. We're talking under 300 milliseconds. Third, with this kind of personal information, data privacy and security are completely non-negotiable. And finally, of course, it has to be built to scale for millions. Every single tech decision we're about to look at is shaped by these four goals. Okay, so where does this whole journey begin for a user? Well, it all starts with creating your digital identity. And this isn't just some simple sign-up form. Nope. This is the absolute foundation of the entire system. And it's all handled by something they call the profile service. You can think of the profile service as the single source of truth for every single person on the platform. It's like a digital passport. Every piece of info a user shares about themselves, it lives right here. It's the central filing cabinet, but for millions of unique individuals. So what exactly goes into this digital passport? Well, you've got the basics, of course, age, gender, location, but then it gets into the really important stuff, the partner preferences, things like religion and education level. And of course, you've got the photos that really bring that profile to life. Now, this is where it gets really cool. Look at how they use the right tool for the right job. For all that core profile data, they use a classic structured database like MySQL. Why? Because it's super reliable. But photos are totally different. They're huge files. So those get stored in something like Amazon S3, which is built for that kind of scale. And to make sure your profile page loads in a flash, all that frequently accessed data gets stashed in a super fast cache like Redis. It's a perfect example of a modern, smart tech stack. All right, profile's done. Now for the main event, the search. This is where the user really starts to interact with the platform, and it's where the search service takes center stage. And let me tell you, this thing has to be an absolute workhorse. The engine powering this whole operation is Elasticsearch. You can think of it like a super-powered librarian for people. It's built to do one thing incredibly well: sift through millions of documents, in this case, user profiles, and find ones that match multiple criteria, like age, and city, and religion, all in the blink of an eye. It's just phenomenal at this. But here's the thing. Just finding people who check all your boxes, that's only the first step. The real magic isn't just about finding every possible match. It's about finding the best potential matches for you. And that requires a whole other layer of intelligence, which brings us to the recommendation service. And this slide just nails the difference, right? The search service, powered by Elasticsearch, is like casting a huge net. It brings in everyone who meets your basic rules. But then the matchmaking service comes in and acts like an expert, sorting through that entire catch to show you the most promising ones first. It's the critical difference between getting a raw list and getting a smart recommendation. So how in the world does it know who's best? Well, it's always watching. It's a learning system. It looks at all these different signals, like how similar profiles are, which ones you tend to click on, whose interests get accepted, and which chats actually turn into real conversations. Every single action you take is basically a vote that helps make the algorithm smarter. And here it is, a little peek at the secret sauce. A person's match score for you is basically a weighted recipe. It mixes in a dash of how well their profile matches your preferences, a pinch of how active they've been lately, maybe a small boost if they're a premium user, and a healthy dose of who you've successfully connected with in the past. It's a pretty sophisticated formula running behind the scenes. So let's put it all together and trace the path of a single search. Step 1, you punch in your filters. Step 2, the search service hits up Elasticsearch to get all the raw results. Step 3, the recommendation service swoops in and re-ranks that entire list based on its smarts. And finally, step 4, the best of the best profiles are sent back to your screen. Simple, lightning fast, and incredibly intelligent. Okay, so you're scrolling, and boom, you find a profile that looks really promising. The search and recommendation systems have done their job. Now it's your turn to take the next step, to make that first move by sending an interest. Now, making that connection involves two key services, and again, they use specific tech for each one. Sending an interest happens all the time, a constant flood of little actions. That's a high write volume problem, so they use a database like Cassandra that's amazing at handling that. Then, for the chat that hopefully follows, they use WebSockets to create that live, real-time messaging feel we all just expect these days. So we followed the user side of the story, but behind all of that, there's just a massive amount of invisible work going on to keep the whole platform running smoothly, safely, and stably for millions of people. Let's look under the hood. So how do you handle that kind of load without everything grinding to a halt? With some really smart strategies. They cache popular search results, so the data breach doesn't have to do the same work over and over. They use a CDN, which is like a network of mini servers all over the world to deliver photos to you from a location that's physically closer, making them load way faster. They use asynchronous writes with tools like Kafka, which is like having a buffer so the system doesn't get bogged down during peak times. And finally, they split their massive user database into smaller chunks, or shards, to keep it manageable. And of course, privacy is absolutely essential. Your contact information is kept hidden until both of you express mutual interest. There are very strict rules about who gets to see your photos. You always have the power to block and report anyone. And of course, all your personally identifiable information is encrypted to keep it safe. At the end of the day, how do they even know if all this fancy architecture is actually working? Well, it's not just about uptime. It's measured by real human engagement. Are people actually accepting the matches they get? Are they sending messages back and forth? And are they finding enough value to convert to a premium membership? These are the numbers that prove the system is doing its job. But, in the real world, things break. What happens then? Does the whole site just crash? Nope. The system is designed to fail gracefully. If that complex machine learning service has a problem, it just falls back to a simpler, rule-based matching system. If the search is struggling, it might show you slightly fewer results instead of just giving you an error page. The user experience is protected, even when things go wrong in the background. All right, we have looked at all the different gears and levers, from profiles and searching to safety and scaling. Now let's step back and see the whole machine in one go, the final blueprint. This one quote just nails it. It perfectly summarizes everything we've talked about. It's a read-heavy system, meaning people spend most of their time browsing and searching. The core design philosophy is to decouple the big services. They use the best tools for each job. Elasticsearch for that initial filtering, machine learning for the intelligent ranking, and event-driven systems to make sure it can scale. It's just a beautiful modern design. And we have to come back to this number one last time. Less than 300 milliseconds. Every single complex step we just walked through, the search, the ML ranking, the privacy checks, all of it, has to happen faster than you can blink. That relentless focus on speed is what makes the whole experience feel so smooth and seamless. So we've seen how this incredible system works today, but it really leaves you with a fascinating question for the future, right? As our technology and our digital lives keep evolving, what new signals could an algorithm like this even use to get better and better at predicting human compatibility? It's a challenge that will keep changing right alongside the tech itself. Thanks for joining this explainer.